Welcome to Closing the Loop, a podcast presented by Lakeside Process Controls, where we connect you with experts, end users, and suppliers in the industrial automation industry. My name is 𝗧𝗜𝗘𝗏𝗧𝗔𝗠𝗘𝗗, Business Unit Supervisor at Lakeside, and your host of the show. Each episode will be featuring special guests from Lakeside Process Controls, Emerson's Automation Solutions, or other industry leaders. We hope that through these conversations, we can quite literally close the loop between your current knowledge and the latest advancements in industry. Our goal is to educate and to provide you with ideas for improving both efficiency and safety throughout your facility. And with that, I'd like to introduce you to today's guest. She's joining us from Emerson's Automation Solutions team, and her name is Shelly Herder. She's a modernization consultant from specifically Emerson's DeltaV team, and we cover a range of topics, and we go really in depth on DeltaV. I have a lot of questions that hopefully you'll find useful and beneficial. So we'll cover, the functionalities, the advantages of DeltaV in control systems and DCSs in general. We talk about, how DCSs compare with PLCs and really the importance of modernization when it comes to aging control systems. And, quite frankly, this sounds like a daunting task, especially when I first learned about this. But Emerson has this Revamp tool, which uses AI to simplify this transition. And it's quite a mind-blowing technology when you see it in action. So we talk a little bit about that. We even talk about Back to the Future and DeLoreans. And so hopefully you enjoy the conversation with Shelly and you learn something. And as a reminder, please don't forget to subscribe if you haven't already so you never miss an episode. And with that, I'll turn it over. Please enjoy the show. Welcome to the show, Shelly.
Hi, thank you for having me.
No problem. And you had a short journey here, as I understand, right?
It was a little bit longer than I was expecting, but that's okay.
You're coming from Texas, right?
Yes, Austin, Texas. That's our
Austin.
PSS headquarters down there.
I hear great things about Austin.
It's great. It's great. I love the culture. It's usually too hot outside for me in the summer. It's getting to that point, but that's okay.
But how does it compare? Like, it's a pretty hot week here in Toronto.
It seems okay.
Really?
It seems fine.
Oh my, because this is like unbearable for Toronto.
I know.
How hot does it? Well, I guess you're going to tell me in Fahrenheit, right? But how hot does it get down there?
I feel like the last couple of years, which is as long as I've been in Texas, it's been sweltering to the point of like I don't want to leave my house in the summer.
Oh my gosh!
It's like 6 months of summer of 90 plus.
Oh my
degree
gosh!
Temperature every single day with no rain. So.
Yeah, we get 1 week and we're like, well, actually, I shouldn't say we because like it's probably just me and a handful. Some people really like the heat, but I don't like we have like a humid like wetness here that I don't like. I don't like what I don't know. It's more dry? I assume in Austin.
It depends on the day.
Oh yeah.
It's not as bad as Houston, but it's in my opinion still pretty humid.
So. Oh, wow. I've always wanted to go to Austin. I've heard great things.
Yeah, you should come down.
I feel like there's a lot of like tech there now, right? Like
yes.
I guess that's probably why it's the PSS headquarters or
it's been PSS headquarters for quite some time, so I think they were there before any of the other tech
they
came.
Started it.
I don't know if they started it, but there was definitely
No, you heard it here first.
There.
They started it. That's what Shelly says. That's so awesome. Okay, cool. Well, thanks for coming out. Yeah, we're going to have a great week. I think you guys are doing some training today, and then tomorrow we have our Lakeside Users Exchange.
Yes.
So that's going to be awesome. I don't know if you know, there is a Back to the Theme future for that.
Oh, I didn't know.
No. Yeah. Well, it was kind of a last-minute theme.
Okay.
I should start off. Have you seen Back to the Future?
It's been a few years.
But you've seen it?
Yes.
You know of it?
Yes.
Okay, good.
For sure.
Because we were kind of debating if, like, which generations would actually understand and remember Back to the Future. Yeah, it's kind of hazy. So we actually have a DeLorean coming.
I was going to ask. I'm like, that's kind of the iconic piece.
Yeah. So believe it or not, there's like a whole network of people that have DeLoreans and they've like zooped it up and customized it, like just like in Back to the Future. They got a license plate that says at a time and you can rent them for events. So sure enough, I dug into this and actually one of our customers, so it's a great story where one of our customers has one. And so he's bringing it to the event tomorrow.
That's awesome.
And then he's continuing on because he's getting married this weekend. So he's bringing that to his wedding. I guess he was debating about bringing it and then this kind of solidified the deal. So
that's awesome.
And I guess I should explain why. It's a Back to the Future theme?
Yeah.
Okay, so listen to this pitch. Tell me what you think about it. But don't be honest if you don't like it, because I don't want honesty on the
my
podcast.
Face kind of says it all. So.
Okay, so the Coles notes of it is, so if you look at industry right now, it's changing, right? And it's always changing, but like it feels like it's really changing and like at a really fast rate. But if you look back at decades before, right, like that's what industry does, is it has to adapt and change with the times. But in all this uncertainty, there there are some commonalities, right? And really, I think the commonality are, at least for us, are molecules, right? Like, we've always dealt with molecules. We're always going to be dealing with molecules. And, maybe everybody's excited about hydrogen now. But, when I started, people weren't excited about hydrogen. Like, it was just this, like, I sized a flow meter for it, and it was just higher pressures. It wasn't anything crazy. But anyways, what we do is we work with molecules. That's our core competency, whether it's, we're controlling them, we're measuring them, everything else in between. So as we go to the future, we're really going back to the future, right? We're going back to exactly what we've been doing, which is our core competencies. We evolve and we have more capabilities, but, together we're going back to the future. So
okay, all right. I could see the thinking there.
Yeah, right. Actually, it didn't start with the idea. It started with, how do we get a DeLorean to this event, and like, how do we make it make sense? And I think I think it makes sense.
No, honestly, I work in modernization, so we're looking at things from the past and trying to get them more modernized. So
Fair.
It kind of fits in with what I know.
Feel free to steal it if you want a DeLorean. There's a network across.
I'll have to keep that in mind for future things.
There's a whole club of people. So,
okay.
Anyway, sorry to tangent to start there, but thanks for being on the show. Maybe for those of listeners who don't know you, who don't know what PSS is or DeltaV, maybe we could just start with a little bit of your background.
Yeah, sure. So my background is I originally was a chemical engineer by degree. So I found Emerson, found controls. I really like the idea of computer science is on top of chemical engineering. So I was kind of like, what does that look like? And I found Emerson, process systems and solutions, and I worked in projects for one of our engineering centers right out of school, and I was there for 6 years. I kind of rose up through the ranks all the way up to software lead with DeltaV. So I've been working on that since I graduated.
That's awesome.
So I found control systems right out of college, and I've kind of stuck with it. So I did work during COVID years, 2020. I kind of wanted to see what else was out in the control systems. So I did switch to a Rockwell integrator for a while. So I did see the other side of things. I've been doing DCS for 6 years. I wanted to see what else was there. Cool. What else was there outside of DeltaV? So I did switch for about a year and a half.
Yep.
Saw how PLCs worked.
Yep.
Did some configuration there and came back.
Yeah. Ultimately, you came back. So the grass is not always greener, right?
I actually use that a lot when we're talking about it.
That's so funny.
But, they have their own things that you use PLCs for, but I was really big into DeltaV, so I really wanted to come back.
That's awesome. Well, that's good. That we've had people like that at Lakeside where, you leave, you maybe go to one of our customers, so go, hey, all the power to you, not necessarily the competitor per se, but then, then they come back and they go, well, no, I kind of, it's funny. I was having this debate with my brother, or not a debate, but just, we were talking about, he graduated from chemical engineering as well, last year at this time. Yeah. And I said, look, Jamie, you kind of are either in the plant, you're kind of in one plant, or you're engineering the plants and you're working with all the plants. So you kind of take your pick, right? And so I said, personally, I like working with many different plants, right? Like, right? Like as opposed to, I guess it's like anything, but, in some places, they only have so much budget. They only have so much, managerial foresight and planning to do certain things. So you kind of get stuck, right? And, you might have all these great ideas, but if, corporate doesn't give you the budget to do that, then you kind of, and to me, that I didn't like that. That could be frustrating. So it's great where, hey, you know what? If one of our customers, they don't have the budget, they don't have the interest, the attention, that's okay because another customer might, right? And that's where I thought was great flexibility. So
yes, kind of got to see a little bit of everything.
Yeah.
At this level and this approach and role, I guess.
Yeah, it gives you diversity and kind of what you're doing. Like, I don't know, you probably feel the same way, but I'm especially at Emerson. But it's like, any given day for any person at Lakeside or any person at Emerson is just like totally different, right?
Yeah, exactly. And that's what people are like, oh, well, what do you do day to day? I'm like, well, it depends on the day.
Yeah. Is it a Friday before a long weekend? Because I know there's a lot of stuff going down Fridays before long weekends. That's awesome. So, okay, so maybe we could start with, you've thrown out a few words there that I want to make sure everybody understands. So PLCs, DeltaV, maybe we can just start with a little bit of basics about, or rather PLCs in general, and then maybe DCS and like the comparison. Yeah,
sure. So PLC, programmable logic controller.
Yep.
A lot of times are seen in small forms. So usually maybe on one set of machinery or one area of the plant.
Okay.
So a lot of times they're in maybe islands. So a lot of times customers will go for a PLC when they're looking for something that is very fast. A lot of times it's discrete, meaning just ones and zeros back and forth, as well as I say fast
and discrete, cheap as
That's
well.
kind of the things that you see, and it's just a controller usually. So it's just one area, one unit maybe. And while there are ways nowadays to combine those, usually it's kind of off on its own somewhere.
Interesting.
So that's kind of the PLC, and then the DCS, distributed control system, a lot of times is more a full plant approach. Has multiple controllers underneath it. Can also integrate into the PLCs in as well in different ways. So it's kind of the full software approach that has everything on top of it. So.
Okay, it's more overarching.
Yeah. So there's more, I guess, how's the best way?
Maybe like scalability.
Yeah, sorry, I'm blanking.
Hey, all good.
But
good.
So...
okay, that makes a lot of sense. And I think PLCs kind of, like I heard someone saying they kind of started in like the automobile space. Like,
yeah, and that's actually one area that you see them a lot of times is automotive, manufacturing, maybe bottling or something. So something that requires maybe something very fast.
Interesting. Okay. Oh, that makes a lot of sense. But okay, and then so DeltaV is a DCS. It's a distributed control system, and there are other DCSs out there besides DeltaV. Okay. So, but does Emerson have their own PLC or equivalent?
So we have a PK controller that we kind of use in the PLC, like when we're talking to customers that previously had PLCs. We also own GE, and they do have mass. I have to edit that out. But, they have PLC options as well over there. So
so there are options to choose from depending on. Okay, that makes a lot of sense. And okay, so if we go into PLCs just for a second, so those are going to be more, just make sure I understand it. So smaller scale, fast pace.
Most of the time, yeah.
Okay, and then DCS is going to be that large overarching.
Yeah.
Okay.
And I mean, if you get into complexity too, a lot of times PLCs are more simple. I have seen some people that have a very complex PLC logic, but it's all in ladder logic. So it's just there's a few different things there that may be easier in a DCS system.
Okay.
Too. So sequencing, maybe batch processing might be easier with DCS.
Okay. So maybe we could talk a little bit about DeltaV then, kind of what makes it special. I want to make sure that I understand everything because I know there's charms. I've heard PK controllers. I've heard marshalling. I've heard all these cool things. Maybe we could just start with a little bit of that too.
Sure. Well, I'm a little biased.
Hey, that's fine. We'll take biased all day.
I've always found, because I've been in there, I've configured, I've done some of the technical work. I've worked with customers, and my experience is that it's easy. It's easy to work with. It's easy to configure. It's easy to update later on if needed. So, I've always found that kind of true, and that's something that a lot of our employees, they say that as well. So it's easy to work with. We have options depending on what our customers needs. So we have, I mentioned the PK controller. It's one of our latest controllers, as well as one of maybe our most robust. It has some options. You can integrate some of those third-party devices if needed into it pretty easily. That's what I...
Yeah. No, that's fair. Okay, so... Okay, that makes more sense. So I'm just trying to put the I think very simply in terms of like, flow meters, and there's different elements and stuff. So if I'm let's say I'm building a plant and I'm going to put in a control system, maybe you can break down for me the different pieces that are needed to build out this control system, because it's some sort of software, some sort of hardware, some sort of wiring. Like, what are those aspects that you're going to need?
Sure. So you'll need the device, so your flow meter. So from there, you get the wiring into let's say we do charms. So charms is our electronic marshalling option, which removes the junction box usually. So another easy thing about DeltaV was our charms. So the wiring would go into the charms, and from there the charms is in a CROC, which connects to the controller, and from there the controller interfaces with our computers or our Pro Plus,
okay.
so our workstations. So from there, we have an I/O network in our software that you configure those I/Os where they came in, and then you do the control module on top of that.
And that
with the logic.
Okay, and that's all the software side of things.
So we have like custom built libraries. So if we have a flow meter, we have loops and AIs, AOs, and all that stuff. That's probably already standardized, and we could just drop that.
Oh, interesting.
Download it.
And away you go.
Should be good.
Oh, wow. Okay.
Maybe some loop checking in there when you get to the site.
And by loop checking, you mean that like confirming that what you put in is what you get out?
Yeah. So that was actually one of my favorite things in projects is once you got done with all the configuration, you went to site and made sure everything worked with somebody out in the field looking at the piece of equipment and then somebody in front of the operator screen and making sure that what you send is what they see and what they see is what you see from the screen. So if you break a wire, you can see that, something's wrong with that. So
it's funny. I've seen that at site where we were going to a site that was starting up, and we had our DeltaV person there, and she was on the radio, and I could, I'm giving this, you're seeing this, and I thought that was kind of, I guess because especially in a project like that's the end of it too.
Yeah, so it's the end. The end is in sight, but also you get to see how the customer uses it, and maybe some of the more things that you don't really think of when you're configuring it in your office. Point. So it's kind of the intersect between what you did and what they see.
Yeah,
so.
Reality and theory too, a little bit. Yeah, I always feel like it's like playing with a big toy. Like, I don't know, it just feels like a big video game too, and you get behind those screens, right?
Yeah, I mean, kind of.
Yeah, like, growing up playing all those, like, I don't know if you ever played any like of those games, 𝗧𝗧𝗘𝗧𝗧 Tycoon or The Sims or anything. Like, I don't know, just felt like kind of in that world of.
I used to play quite a few games.
Yeah.
There's actually like automation games these days. There's one like Factorio. Yeah,
no
it's
way.
Literally you're operating a plant.
That's hilarious.
I've never played it myself, but I know some people.
Factorio? I'm going to write this down.
Factorio, yeah.
Wow, well, shout out. Maybe they'll give us a sponsor. Wow, that's pretty cool. Okay, so this is making a little more sense. For me, it's like a lot of the conversations are just, and then wire it to your control system. And I hope you know what to do there because I don't really. Okay, so that's not always that simple, right? Sure. And so you brought up something. So there's the use of charms and there's the use of controllers. So maybe help me understand a little bit about charms. I'm not going to ask you the acronym unless you know it.
It is characterization module.
Oh, okay. Actually,
it's
I feel like
CHAR and then M.
Yeah, so it should only be CRM, but okay. Yeah, you don't want another CRM acronym, right?
Yeah.
Okay, so explain to me what those characterization modules are, just very simply, if I say.
So in a traditional wiring, usually you have an I/O module that sits on your rack that is usually colored or flavored. I don't know the right word. Yeah, flavored to be a certain type of I/O. Yes. So like an analog input. So that I/O module is usually just AIs. For analog inputs.
Yep.
And then you have one for DIs and et cetera. So those are all split out like that. And then those wires are going to a junction box, then split out into the devices in the field.
Oh.
So they have a little bit more wiring because they're all landing somewhere in the field and then distributed from there. With charms, you can have different I/O types right next to each other. So instead of having to wire to a junction cabinet to combine everything and then bring it in per I/O type, you can do it all in the cabinet or wherever the charms are. So it takes out the junction box and it allows you to kind of have whatever you need all in one area. And so the flexibility is greatly increased, as well as if you have later changes, you can easily add I/O right next to what you already have. So
it's funny because like what you're describing is basically all I know. So it's like there is another way to do it. That's not that. That seems really okay. But the flexibility I think is something that's really interesting because I know we were talking about, especially for large like greenfield sites, CapEx projects, like like you said about meeting reality, right? Sure. Like you can plan all you want, but if you only have your fixed, I/O points set, like, and then now all of a sudden you need to add a new flow meter, you need to do this, you need to do that, like. How are you supposed to do that with a PLC, I guess, right? Like, it's tougher.
Right, and assuming they had spares assumed in there.
True.
They might have space, but this just allows the wiring to be a lot more simple at the end if needed.
Yeah. Well, if you ever open up a PLC, I know it's PLC and not DCS because it's just this spaghetti mess.
I've seen some in person.
Yeah. Well, and then like I know when we were talking about it in a bit, but like, I can't imagine ever upgrading that. Like, to me, that just seems like such a nightmare of like, oh my God, I think about my desk at home and how many wires I have. I can't imagine like running a plant
Cable
off this
management.
thing. Yeah, right? Like,
it's an art.
Honestly. Okay, so that's interesting about the charms. And so the charms, because I always see them as part of the cabinet, but they can be in the field?
Yes. So sometimes when we do retrofits or modernizations, instead of putting, maybe they don't have enough space in the cabinets, so they might have space in the junction boxes, so they can put a charm 𝗧𝗓𝗔𝗬𝗦, which is the part that you can bring into the controller. You can put those in those junction boxes, or you can put them near the devices. We also have distributed charms that come in little smaller boxes that have like 12 charms, so those can be even more versatile and flexible to put in the field. Okay.
And so you talked about like just not having enough room. Are there any other benefits? Like, so let's say you have those 12 charms that are then going to all the, like, can you bring it back with just one wire to the actual controller, or do you still need 12 wires back? Like with like Ethernet or something, or maybe that's like a future advancement.
I would have to double check.
Okay.
I think it's Ethernet for the distributed charms.
Oh, well, that would make sense to me. The little I know about Ethernet.
The 𝗧𝗓𝗔𝗬𝗕s itself might be more of a fiber cable or a bigger set of wires.
Okay.
I would have to double check.
I feel like that makes, well, I don't know if that's not just willing it into reality.
Sure.
But I feel like that'd be cool. If you haven't done it, you should do it to save the wiring. But
I think, I'll have to double check.
Yeah,
I will say I'm more strong on the software side.
Yeah, okay. Well, we'll get there. We're working our way there. Don't worry.
I know.
Okay, so I get the charms and then the controllers. So that's help me understand what the controllers are doing, because that seems like intermediary between the software and the.
Sure. So the controller itself is what runs the logic. So on the computer, we'll do the configuration, and then we assign it to a controller, and then you can download it to the controller. So once it's downloaded, it's live on that controller, and it's doing the logic. So
it's like a mini computer?
It's a mini computer, yeah.
Oh, really?
Processing unit of sorts, yeah. So.
And its job is just that one control loop?
Well, whatever is assigned, so.
So it can be assigned more than one control loop, potentially?
Oh, quite a bit, yeah.
Oh,
so,
really?
like our PK controllers can do up to 1500 I/O, which doesn't mean control module, but it means it can have 1500 I/O come in, and then they would have control modules on top of it that's running those I/Os.
Oh, okay.
So it can do quite a bit, and usually for our PKs we do separate it by DSTs, but it's the control expansion control level as well that is.
Oh, wow. Okay. So you might only need one PK controller in some like smaller, like if you're replacing a smaller PLC, you might just need one PK controller. Oh, wow.
Yeah. So one controller and maybe one CIOC, which is just what works with the charms. So.
Okay. Sorry, what's the CIOC? You keep saying that.
I know. I keep saying it, but I'm like, I don't actually have it.
There's too many
charms, IO.
Charms again.
It is. It's an acronym within an acronym.
That's okay.
Sorry, I didn't need to know what that
was. No worries. Okay, but that's interesting. Okay, because I wasn't sure how many controllers that you need. So that's okay. So in like a large scale plant, you still might only need so many. You're not going to need potentially hundreds of controllers.
Sure, and a lot of times people will split those based on units, based on areas.
You said DST?
Sorry, DST is.
There's just too many acronyms.
You're right.
Okay.
Put me on the spot again.
It's all good.
It'll come to me.
Yeah. Okay. Well, let me know when it does. Okay. So we have our instruments in the field, then we have the various charms, and then the controllers on top of it. And then now we've made our way back to DeltaV.
Yes.
Wow. Okay.
Digital signal tag.
Oh. Okay. So when you said break it up by digital signal tag.
Yeah. So IO or signal tag is usually.
Gotcha. Okay. Yeah. I've heard it by. Okay. That's interesting. Okay, yeah. So that seems to be the elements of your control loop, then, or at least your control system. So then you get your DeltaV. That's the
Yes.
fun side.
That's the fun side for me, at least.
Well, that's what does look like the video game to me, is the DeltaV side. So once you have all of the hardware in the field, talk to me maybe a little bit about, you know, how we maybe start up a system, how we build a system, all of the logic, the interface. Just for a little bit of background would be great for me.
Sure. So a lot of times our engineering centers or impact partners will split that between software and hardware. So we have a hardware team work on the electrical controllers, make sure the architecture is right, make sure we have the right amount of licensing for what the customer has, and then the software will tackle the control logic. So, we usually split those based on that. And if there's anything else, maybe application-wise that they're needing, like AMS or maybe something with Agile Ops, that might be a third person or a team that might handle that, or maybe it's split up. I probably is dependent on
the situation
teams, but so if we are looking at greenfield or new, a lot of times the software will come from the logic diagrams, etc. It might come from a EPC engineering project consultant, I guess.
Yeah, there we go. I was trying to think.
I'm trying now to remember all the acronyms.
I should know EPC.
But yeah, usually that'll be in like
so they'll provide it.
They'll usually provide it, and then we would take that and bring it into DeltaV. So
that was the part that I was going to ask next, because that's what I was. So now that we've got everything implemented on site, but the software, like who designs that? So typically, I guess in a greenfield, EPC, and then we just program it based off of what they're looking for.
Yeah, and so that's greenfield, and then brownfield a lot of times we'll take what they previously have, their old control logic, and we will put it through Revamp, and we'll get some logic to begin with for the reverse engineering.
Okay. So. Well, and that, like, to me, it does sound like obviously it's a very complex process. So, like I said before, I can only imagine, like, it's one thing to rip out a flow meter and replace it, but to rip out your control system.
Yes.
Not only does it seem like a nightmare for wiring, and dealing with all that, but the risk, right?
Yes.
Like that's how you're making money.
Yes. Yeah, it can definitely be a high stress situation, especially during those loop checks and commissioning when that's shut down.
Yeah.
So
every day you're not making money.
Yes.
So what would be some of the reasons why a customer might want to switch control systems, right? Like, I feel like, status quo is a very comfortable place, right?
Right. Well, a lot of times their systems just aren't, they're old. A lot of times they'll hold on to those as long as they can, and that's understandable, especially if they maybe don't have the budget to constantly upgrade. So a lot of times we'll see quite aging systems.
Oh yeah.
And you don't really want to get to the point that you're worried it's just going to shut down everything, though. So it's like, okay, well, you need to think about it. And each part, like the graphics or the control system itself, the workstations, the controllers, they all have like a age span that that you can kind of, on average, assume that you might need to replace it every 5 to 10 years for one of them, or 10 to 15 for the next. Maybe the wiring is probably the best thing that stays, and it's good for a while, as long as you're not constantly upgrading. So if your system's not changing too much, the wiring might be fine, but maybe some of the other things might need to be looked at. So yeah, that's one thing. And then reliability, I mean, I guess that is reliability, but maybe advancement in technologies. Maybe they want to be able to monitor from their offices across the state or province or country even. So advances in technology is definitely a driving force as well. So
that makes a lot of sense. What when you say old, what would be considered old in the DeltaV world?
Oh man,
is it 10 years? Is it 20? Is it 30? Just if you had to guess. Like to me, like an old flow meter might be 20 years old.
I would say 20 plus sometimes.
20 plus, yeah.
Maybe 15, 20, 30.
Yeah.
I've
probably similar range then.
Yeah. So.
Yeah, and then I mean, a lot of times though, I mean, some of the problems we have is sometimes our stuff might be old, but it doesn't mean it's not working well.
Right. Yeah, and definitely, I will say that they used to build them to last.
Yeah, I know. Well, that's like I think I might have mentioned it on the show before, but we have one customer who they have a project to upgrade our 1151 pressure transmitters, which have been discontinued for I don't even know how long now.
Yeah.
And they keep pushing out this project every year because they go, yeah, you know what? These 1151s are still working great, right? Like, yes, there's cool new advancements in technology that, we benefit from, but we don't want to just rip out, 300 pressure transmitters and replace them just for this.
Right,
we want it like beyond that cusp of, okay, these are now like outdated technology and they're not working, or on the cusp of we're having issues, but they're like the Energizer Bunny. They just keep on going.
Yeah. It is amazing sometimes to talk with some customers and they show you a photo and they're like, do you know what this is? And I'm like, I think that's older than I am for sure.
A lot of times. Yeah. Yeah. Sometimes you're getting like spec sheets that are like, yeah, definitely. I'm not going to say the year, but definitely earlier than the year you're born. And you're like, oh my God, this is still written by hand, right?
Yeah. Well,
yeah.
Well, in modernization, that is it's common.
Yeah.
So, and another thing is, a lot of the workforce that is used to the older stuff, they're aging, they're retiring too. So new people getting out in the field, they see something that's older than them and they're like, we don't want to work with this. We don't want to have to learn this.
Well, they don't know how to, right?
Yeah. And they don't even know how to approach it. So and maybe that's a very small percent, but that also happens. So
no, but you want something that your people, your employees are going to be comfortable with. And if especially if you're not learning in school anymore, right?
Yeah,
if some of this, especially for the hands-on, right? If what you worked on with in school, university or college,
exactly.
right? If that's gone and obsolete, and you're trained on something else now, and then you have to go back. It's like, oh my God, I went to school, we learned about latest and greatest, and now we're on good enough, right?
Yeah. So that's definitely something that we see occasionally as well. Is no one's excited to work with older stuff sometimes.
Yeah, no, I do get that. I mean, if I equate it to a computer, right? Nobody wants to use an old computer, right?
My goodness, that takes 10 minutes to load.
Yeah, Windows 2000 or something. Actually, I feel like, I don't know if we have XP on any machines anymore, but I feel like there's a couple of them that might be almost that old. Yeah.
I've seen a few VMs.
Yeah, and it's like a blast from the past, right? Okay, so those are some good reasons. And so I guess logistically, you kind of already got to where I was going next too. Is you can, let's say we're upgrading our system. We've decided that we want to do this.
Yeah.
What is that process look like, right? Hey, okay, I want to buy new control systems, please. What is that process? How do we get to that point where now they're operating with DeltaV?
Sure. So a lot of times they'll reach out to our impact partners or our sales force, depending on what part of the globe you're in.
Yep.
They'll reach out, kind of ask them what might be what it looks like, and do we have options for them with their specific control system, and what would that look like, and what's depending on what they're needing to fit their budget, etc. We can provide them some products to get them from point A to point B, and sometimes it's a phased approach.
Yeah.
They need that information to make that decision. So a lot of times we'll have customers into our headquarters in Austin. I'm sure there's other locations like at the Impact Partners as well to kind of come in and see what we have. So that's usually one of the first starting points, is kind of get them in front of the equipment, show them how it works, and kind of talk through some of the technologies and advancements and what they would be gaining by possibly upgrading.
And maybe what parts that they're interested in, or not interested in different features.
Right,
okay.
Yeah. Sometimes, because our modernization products, we kind of offer something for if you want to get rid of your controllers but keep your I/O. If you want to get rid of the I/O too, we have some solutions for that. Or if you want to just rip everything out, which is great as well, which I personally prefer, but I understand customers need something maybe in the middle sometimes. So we have a range of products usually, depending on the control system, that might be desirable for their specific needs.
Okay, that makes sense. So then, so let's say now, hey, I want to rip it all up from scratch. this is a lot harder than quoting a flow meter, right? Like,
Right.
So I imagine there's site visits, there's
Yes.
audits of some sort to figure out, like, what do you have? How many are you going to need? Like, so how does that process work?
Yeah, so a lot of times that's usually the impact partner or maybe the engineering centers coupled with maybe somebody from my modernization team that I work with. Sometimes will accompany them as well. So they'll go to site, they'll do a site walk down, maybe take some photos, talk to the customer, understand their pain points, and try to figure out maybe what they're looking for. So kind of understand that as well as see what they have, and then go back and maybe provide a proposal, depending on what the customer is looking for.
And is that based on like I/O points and stuff like those?
A lot of times, yeah, it's based on I/O points, maybe what packages they're looking for or software applications.
Okay, that makes sense.
And maybe depending on what state their system is in as well. So
Okay, well, that makes a lot more sense, yeah, because to me it was always like, this seems like a big hurdle, but maybe it's not as big once you go to site and do the audit, because everything's going to be in that cabinet, right? And
right.
Like
cabinets usually.
Or multiple cabinets.
Yeah, quite.
Yes.
There's usually quite a few cabinets to go through.
Fair. I'm used to probably just seeing the ones that are in the field anyways. Like
the pristine.
Yeah.
No.
Yeah. Okay. Well,
okay.
that makes sense. So now, hey, I want to upgrade. I know what parts I want to upgrade, and now we have a proposal. But the big daunting task, how do we actually do that now, right? Like, I shut down, you rip out my control system. How do I now? Is there a tool for this?
If we're looking at specific control systems that they have, we do have a tool called Revamp.
Yep.
That is an internal tool that our employees at our engineering centers and impact partners they use, and it's self-service, so they're able to take whatever the customer provides them as like backups from their control systems, and they can import it in themselves, and after a while it comes out with a knowledge base that allows them to understand what the customer has within the logic itself as a starting point, as well as some details for them to start the reverse engineering process.
How long does it usually take? Is it like a minute, 10
Depends
hours?
on how big the system is.
Fair.
But I would say less than an hour most of the time.
Really?
Yeah.
Wow. I feel like that's pretty insane. Like, I can only imagine trying to do it by hand.
Oh, gosh.
Like, if you had like 1,000 I/O, like, I don't know, that must be...
Right. And no, that's just giving details. From there, they'll take that, and we have a few other internal tools that then they would take the export from that and then run that through, and that might take a little bit more time to get the base layer in DeltaV. So...
like, how much longer would that be? Like, is that software, or is that someone actually sitting down?
A person would run it through, so all that has been digitized already, so it's a digital workflow. So there are certain mapping details that are done specifically for specific control systems that we have.
And so when you say mapping, it's like this flow meter is reporting back its value here. We're now controlling this valve based off of this. Here are set points based off of this. Like, that's the
something
mapping.
like that. Yeah, like PID tuning in certain DCSs might not be the exact same because of the unit differences or something. So it would translate that and make sure it's in the right units, set up how it needs to be in DeltaV.
And like units, like literally like Fahrenheit versus Celsius is
Minutes
like a standard.
versus seconds usually is the one that gets us.
Oh, really?
Well, it doesn't get us, but
no, but it's the change.
That's what you got to make sure to. You know what you started with, you know what you're going to, and so how do we make sure those map or become correct?
Okay,
so.
and it uses some form of AI, right?
Yeah, so we use a little bit of artificial intelligence.
And real artificial intelligence, not the fake stuff everybody keeps talking about.
We use a little bit, yeah. So
that's pretty cool.
So yeah, we take our customers' detail within a cloud-based server that is within the Emerson firewall, so it's secure. So we take those details and we run it through, and as it's seeing more and more data, it's taking notes. Not keeping customer data, but keeping notes as to what it's seeing, like a pattern or something. So it keeps notes of that, and then as we do more and more projects, it gets smarter. So it's got a feedback loop in there that allows us to continuously improve. So there's that portion, and then we've also continuously added onto that. We've added some copilots, some large language modeling, for certain areas of our reverse engineering that allows us to get closer to something that is more of a narrative versus looking at a whole bunch of lines of code.
Interesting.
So
in terms of the learning, so like, let's say, it's trying to back engineer, this mapping and this little, let's say we're just focused on one loop.
Sure.
So let's say it does its, first crack at it and says, here you go. And then you go in and say, well, not quite. Actually, it should be this. Is that how the learning happens? Like it recognizes the human changes after, or
it recognizes it as a new pattern, maybe. So
okay, and then builds
it's
up
like
all the different patterns.
So we started with a standard set that might have been. I don't remember how those came to be, but I believe our experts started with those, so they were inputted in. So it's looking for these specific ones, and if it identifies it, then it says, hey, you found a match. And then that's probably the loop. But if you see one that's new, it's like, okay, well, there's a new match. It looks like this loop. Let's call it loop. So
gotcha.
It's kind of paying attention to what's previously there and adding on to it. So
wow. Well, that sounds like a huge time saver.
Yes, that's definitely one of the benefits.
So what would we do before Revamp? Like, how new is Revamp?
So there's been tools for modernizations for maybe, I'd have to ask my colleague, but I think around 10 years.
Yeah.
But most of it's been, hey, who in the modernization team can help me run this tool that's that's sitting on their computer? So they would send it to them, and it would be done. Maybe it was like VBA or something. I don't remember what they were using, but some kind of tool that would provide it, and it would be given through a little bit of manual intervention. So
gotcha.
So it's now more available, easier to access.
Yeah.
So there's not the
you're not sitting around waiting.
You're not waiting a week.
Yeah.
For the majority of the ones that are on Revamp.
Okay.
So I mean, there are a few tools out there just because of business needs that are still done in that way.
Yeah.
But, we are constantly pushing to have them more available to our engineers.
Okay, so that makes sense. So it's more easily available. It utilizes AI.
More standardized too.
So everybody's doing the same thing, and then it builds off of it. It's a centralized place, so it gets better and smarter. So, okay, does it give you suggestions for improvements? Like, hey, you're doing this, but a lot of people do it this way, or is it more just going, hey, we just want to run your plant tomorrow in DeltaV? Like, it's more of that.
I think right now it's not giving you suggestions like that.
Okay.
That might be more of the expert looking at it and be like, oh, maybe we should consider this for the future. But maybe in the future that might be something that is more accessible. So
that's what I was thinking.
More added in.
What you start seeing is like this is kind of not a standard way of doing things. Would you consider this? But I guess the whole priority is like we don't want to be as down. Like we want to be down for as short as we can while we're doing the upgrade and like worry about future optimizations later, right?
Right.
Okay, that makes sense. And so like I guess you can't just set it in this program and then walk away, right? Like so what? Maybe you can walk me through a little bit of like you said that there's the second part of this, and then there's the human intervention where you're doing the back engineering. Like what does that process look like, and how long? Like you got to go through every loop, I guess, one by one, right?
Sure. So we always say about 70% is done with the revamp automatically, average. And then that 30% is what is left as like a report for our engineers to look at. So maybe something custom that isn't based on a pattern. So it's like, okay, maybe you should look at that. Maybe it's an interlock that wasn't obvious. But it gives you full documentation of what was previously there. So if it was done within the 70%, it says, hey, I did this. And it matched this pattern, so it went through automatically. But maybe this one was a little different enough that it needs to be looked at, and maybe either make that mapping downstream to make that work, or do it within the DeltaV system once everything else has been imported in.
Oh, so it'll automatically tell you, hey, these ones went through exactly. Don't even worry about it. Like you don't.
Yeah, you get the list. So
interesting. So, but you can go, but you don't have to. Like, you don't have to go through all 70% of those, and there's no point because it's just a 1-to-1 match. Here you go.
Right.
Super easy and simple.
Yeah. So I mean, if loop A looks like loop B, and I've seen that before. I don't really need to look at that until maybe the FAT or factory acceptance testing, and we can look at them. But since I knew that it was done in that way, they might take less time to look at it, because it's like, oh, well, if it was done automatically without human intervention, then there's less chance of there being something wrong with it. So they could focus on that 30% a little bit more in depth with their amount of hours that they have allotted, and actually get something a little bit more substantial there. So
interesting. So I'm just thinking back to, we had on 𝗧𝗜𝗏, and he was we call him the Looney Tuner. So he's like our loop tuning guru, been around for 30 plus years. Yeah. And so this is guy at the interface where now he gets involved when and so I think it's these 30% of, he had some cool statistics about how many loops are causing errors and like alarms as a result, but it's those 30% that I feel like he really focuses on.
It could be, because
a lot of them might not even need to be specialized or different, right? Like it could just be humans getting involved and making things more complicated than they need to be, and like
it very well could be. And I didn't get a chance to listen to that episode, but
you'll love it. He's great. 𝗧𝗏 is awesome.
All right. And a lot of times when we put in tuning values for everything, it's based on that previous system. So what we're bringing in is definitely a good start.
Yeah.
So, but during startup, it is always recommended to make sure those loops are tuned as they need now with the new control system. So that is still definitely a step that should be looked into once they get to site with the actual equipment.
Should be.
But
because I kind of feel like, when you're like, we just got to get running, we can worry about getting better later, right? I imagine that's the same, like, okay, yeah.
Yeah, and a lot of times while you're loop tuning and you're going, oh, well, send me 50%, send me 75%. Sometimes they're like, oh, well, I don't know what it's doing, but it's bouncing. So they might be able to take note as they're doing loop checks and be like, you might want to listen in on that PID. It's a little chatty or something. So
listen in because it's chatty. That's funny. I haven't heard it like that. That makes sense, though. It's just because it's just sending you noise. That's funny. This is what happens when you're on the MSOL world. You don't hear these fun, our things don't talk to us.
Well, I just kind of came up with it. So.
Oh, really? Oh, I love it.
Who knows? I probably heard it from somewhere. But.
Maybe. Okay, so that's cool. Okay, so then, and then once we've gone through this whole revamp and now we have done the remapping.
Yep.
I guess, so that happens maybe before we've even installed anything on
Oh, yeah,
site?
This is way before installation. So I guess backing up, so project execution, usually you do the configuration, you kind of talk back and forth with the customer, they look at the graphics, they look at the control system, and then they have an FAT with the customer, which, again, FAT is factory acceptance testing. Usually, they usually do one with software, probably one with the hardware checkout just before it goes to site. So they definitely do testing. There's internal testing and then testing with the customer usually, just to make sure everything is as it should, working fine, no gotchas, and then you go to site with the work. So there is a few things, steps in between it with the execution still.
Okay.
So.
But basically, by the time you get to site, you're really just hooking up wires.
It should be good at that point, yeah.
Hooking up wires, testing loops, right?
Yes.
Okay. So
you don't want to be reverse engineering once you get to site. So,
yeah,
so usually the shutdowns are usually just that part. So while Revamp does save the hours, it's usually more hours in the configuration before before you get to site still. So maybe like hey, we want to do this in 3 months, right? Well, maybe now it's possible. I don't know if 3 months is unrealistic, but like, sure. Like we have a tighter timeline to do this. We now have budget. We're going into shutdown. Like this now saves a bunch of those hours and the time makes it more possible. Yeah, I would definitely say in 3 months, depending on the size of the project, might be actually what they're looking at. So that's, so, and in addition to the revamp with the charms, that shorter timeline also is helped a little bit, so.
Okay. And I don't know if this is part of your expertise here, but is this where, when I keep hearing about like a factory twin or a digital twin, like is that kind of where this might get involved, where now you have a simulated plant that you can then mess around with and test at this point, or is that maybe more in greenfield? We definitely do a lot of times add mimic or simulated tieback for internal testing as well as customer testing. Usually there is another layer of that can be
included, and I'm not super good
Fair.
with that. Those
fair.
details.
Well,
I know a little bit, but not enough to have further conversation. Probably
that's totally fine. Well, that part is where I think it starts connecting back to chemical. Like I did chemical engineering too. I used @Tech in school.
Okay.
So it's just kind of funny now that like, you know, when Emerson acquired and like it's kind of back in the world, it's like, oh, this is cool. I use this software in school. Like, and so I'm just picturing back to, I don't know what you did for your capstone, but we had to do all these simulations in Aspen, and it was like we basically built the plant in Aspen, and it was like you were graded based off of like we were building. I think like it was biodiesel, if I remember. It was like you had to create a process, and you had to, you know, like literally totally simulate it from scratch. And here's the efficiency of your process.
Oh wow, okay.
Yeah. And then there was like modeling for costing and like and how efficient you were. And I remember we had some statistic where it was like, yeah, so our plant that we made was so profitable. It made like it like made like $1 billion every quarter. But if we ran our plant, like the average life expectancy of everybody in the world would go down by 2 years every year it operated or something. I don't know.
Wow.
It had these cool things it would tell you, but it was not, we couldn't really sell that. So we had to write a letter to the prime minister. Why it was a fun project actually.
That sounds awesome. I feel like our unit ops or our last kind of thing in school was not as to that level.
Oh,
so
yeah.
That sounds awesome. I think we ended up making like a vaccine plant. They went very bio for our specific one. So.
Oh wow, maybe it was the time. That was what they're interested in.
I guess that was right. I don't know. I think it's kind of random, but yeah. So.
Oh wow, yeah, it was. I don't know, it was pretty cool, and like thankfully I had some really good group members who were really good at this stuff because it was like, well, I remember like we couldn't even get the software on our computers because. You know, at the time, it was like $20,000 a license or something, right? And so you had to go to the computer labs, and so we spent so much time. I remember being there for like one day it was like 12 hours straight,
oh my gosh.
and we didn't even leave to get food except they have a hot dog stand.
Nice.
At McMaster's where I went.
Sure.
It's called Willy Dog. Shout out to Willy Dog. And it was like we went out there, we got Willy Dogs, and then they happened to be selling Krispy Kremes, like
very nice.
4 for like a dozen or something, or sorry. 12 for 4. Yeah, that's it. And so we just had Willy Dogs and Krispy Kreme donuts and Aspen. Like those are the 3 memories that I associate.
That's amazing.
Yeah. Anyway, sorry to derail, but that sounds really cool. Maybe could you talk to me about a little bit of like forward looking of where do you think, you know, Revamp goes from here, maybe how it gets better or what customers are asking for? Yeah,
sure. So a lot of times what we add is based on business needs. So if we see that there's a lot of customers coming in that have this specific control system, we're like, okay, well, how can we incorporate that into Revamp? So there's two different things to that is the technology itself as well as the control systems that we can work with. So control systems based on business needs, and then the technology advancements it's kind of sky's the limit. If we can think of something that makes the most sense and would be the most helpful for our engineers, we'll add it. So like the large language modeling was one of the newer things. Lately, we've been looking into ladder logic. So it's not necessarily an AI advancement or anything, but we're using specific different types of technology in the background that is able to handle that a little bit better than our previous versions of Revamp. So,
awesome.
So depending on the business need, depending on what we can dream up, kind of.
And so, yeah, that actually did bring up a good point that I don't think we covered before was that Revamp only works with certain control systems right now, right? Like that's as we see more. We keep adding to it as we see that we need it. So, and like I said, we do have other tools for ones that aren't actually within Revamp that are accessible still by our team. And so it's maybe not as advanced, though, as the ones that Revamp provide. Okay. So I feel like we have a solution for almost everything in some way or another, tool-wise for software. Okay. And then also, one of my adds to the Revamp team and technologies has been trying to incorporate graphic conversion too. So cool. I know we didn't talk about graphics too much, but on top of controls, you have the screens that the operators use to run the plant. Yeah. And sometimes those can be thrown through Revamp too. So it looks the same almost. It's
the same look and feel, but within the HCD or human-centered display coloring and into DeltaV Live. So so that's been something.
I never even thought about that piece of it.
Yeah. So we've been looking into ways of doing that as well. So.
Oh, wow. That is pretty cool.
Yeah. So
can you share what the control systems that we can do with Revamp, or is it a large, long list?
There's quite a big list,
Okay.
So I am talking at the user exchange tomorrow as well as today to internal, but I do touch base on some of those if the customers are going to those.
Okay, but I assume probably the ones that you see the most frequently anyways are going to be there. So there's a solution probably.
Yes.
Yeah. Well, there's definitely a solution. Whether it's Revamp or not, at TBD.
Thank you.
Yeah, okay. Oh, that's awesome. Cool.
Yeah.
Okay, so, well, thank you so much for your time.
Yeah,
I feel like I learned a lot about DeltaV. I have a lot of questions. I've always wanted to learn more about DeltaV. I feel like it's been this big mystery that might be a little bit simpler now.
Okay.
Still, I think executing is much more complicated than having a basic understanding of it. But so for anybody listening, if they want to learn more about DeltaV or Revamp or anything else in between, where could they go?
You can definitely go to Emerson.com. You can go to your local impact partners in the area. You're also welcome to reach out to me. You mentioned LinkedIn earlier, or maybe that was
pre-chat. LinkedIn works.
You can, LinkedIn is fine as well. I would say my email address, but a lot of people spell my name wrong. So,
just through the Emerson website, we'll get to
Emerson website. Yeah, if you have a control system that you're interested in, there's like forms you can fill out, and it'll eventually get to us too. So, and I've seen a couple come in that way.
And there's lots of even documents too, like DeltaV. The PSS team does a really good job of, hey, you have this control system, and you I've seen so many of those.
And we definitely do try to keep those up to date as well. And I was going to say also there is a YouTube that talks about Revamp too.
Oh, really?
And my boss, Aaron Cruz, worked on that, I think last year. So that is available. The back of my head is in part of it. So.
You're basically famous.
I know, right?
That's so awesome.
But if you are interested more in the process, it does kind of walk through and show a little bit of what we show in Revamp. So,
that's awesome.
So that's a good place too. I don't remember what the exact YouTube plug is for that.
I'm sure you can find it.
DeltaV Revamp, I think we'll find it for you.
Emerson's pretty good like that. I mean, you can even just Google it, and it's probably a related video, right?
Yeah.
Okay, awesome. Yeah. Well, thank you so much for your time.
Well, thank you.
Yeah, it was great having you out. I'm sure tomorrow and today is going to go great.
Yes, I'm excited. I'm looking forward to checking out Toronto while I'm here too.
Oh, it's great. And it's, I guess, colder for you, so that's a huge win.
I think it's perfect. I'm always in a long sleeve. I'm not right now, but I do have my jacket, so
that's hilarious.
It's fine.
Wow.
So.
Well, there's no snow, so you had to come back next time when there's snow.
I've heard. Maybe someday.
It's not all it's cracked up to be, I'll tell you that much.
Well, I grew up in Kansas, so I am used to a little bit of snow.
Okay, so you know of snow, yeah.
So not as much as probably up here, but I've seen it, I've touched it, I've played it as a kid.
Totally fair. Cool. Okay. Well, thank you so much for everybody still listening. Thanks for joining. Be sure to subscribe so you can stay tuned for all of our latest and greatest industrial automation. And until next time.